So we're just going to quickly touch on the RAM512 HDL code. So we have a 16-bit import, a load bit, 9 bits for the address space, and the output is going to be 16 bits. Now how this works is we're going to use a demultiplexer 8-way. Basically we're going to put the load as the input. We're going to select, we're going to use from the address space, we're going to use the most 3 significant bits. Now based on the address, this is how we're going to determine which RAM 64 we need to sort of jump into and go to the lower level to find that particular address. And then we have all of the output of those RAM 64s feeding into a multiplexer 8-way 16-bit. And then that's going to be determined based off the address, and then we're just going to output that. Now, this is pretty much the same concept for the 512 and the 4K. The only difference being that the 512 is, you could say, on a lower level, a bit Inception-like, and the RAM4K, the only difference being really is the address space is going to be a little bit larger because we now have more addresses. So, but the same concepts apply. So we're still going to use the demultiplexer 8-way. We're still going to use the most 3 significant bits to determine the 8 RAMs that are within this chip. And then we're still going to have the multiplexer 8-way 16-bit on the other side. That's going to output the RAM based on the selection address, and then it's going to just output it. So what I'm going to do now is just quickly test these programs, starting with the RAM512, and they should run successfully. So I'm just going to quickly load that up now. And we'll just quickly set that to fast and quickly test it out. So basically what the test is doing is just setting addresses, and then also it's just playing around with the load function. So are we reading or are we writing to the RAM? So as you can see here, we've got the RAM512, end of script, comparison ended successfully, which basically means that everything is working as it should. Now I'm going to quickly jump on load in the RAM4K. The HDL kernel loaded, and now the script. Now we'll test this out. This is basically just doing the same thing as well. So when load is 1, we are setting something into the address, we're writing to it, to a particular RAM address, and when load is 0, we're reading the address. Okay, end of script, comparison ended successfully. So the RAM4K is working as it should as well. Thank you for watching my video.